Let me show you something cool. So what just happened here? This power supply created a current, a flow of electrons traveled over here to a capacitor. Now a capacitor is two metal plates in an insulating oil. Charge can't flow through the oil from one plate to another, so it builds up on one of the plates, charging it negatively. The other plate is left with a positive charge. This creates a potential difference, some voltage across the capacitor. Potential difference is kind of like potential energy. The more charge you build up between the plates, the more voltage you have, and the more energy you have stored in the capacitor. I've been charging this capacitor for about 20 minutes, and it's charged up now to about 3,000 volts. So that energy just sits there until I flip this switch. When I do that, I'm completing a circuit where an iron wire connects the two plates of the capacitor. Imagine destroying the Hoover Dam. Huge water flow. It's the same thing here. Electrons will rush from the negative plate through the iron wire to the positive plate, and the wire can't handle all that current. You might have heard about Ohm's law in physics, V equals IR. Voltage equals current times resistance. Now the voltage in the capacitor after it's been charged up is going to be really high. And the resistance in this wire is really, really small, so the current going through it is going to be huge. When current flows through anything with resistance, even if it's just a little resistance, energy is dissipated in the form of heat. The huge amount of current leads to a huge amount of heat that the wire can't dissipate, so it explodes instead. Now the wire actually explodes before all the charge can finish leaving the capacitor. So I'm going to take this copper bar and touch it to the two capacitor plates so it can finish discharging. Now the thick copper bar has a way higher resistance than the thin iron wire, so it dissipated the energy better and didn't explode.